mediano, 40 15 minutos, pero ya. A ver, este me pone, ok, live streaming. Estamos en vivo ahora.
Sí.
Pero me sigue sin oír.
Sí. Vale, esto está en directo.
Ahí mismo, ahora.
¿Estás en silencio tú?
Sí.
Quítate el mute, a ver.
¿Ahora? Hola. Hola, hola.
¿Cómo consigo que se oiga al ponente?
¿Soy a dónde?
Aquí, a la sala.
¿En la sala?
Sí.
¿Qué ordenador utilizas este? Este. Pues como hay que encender el...
Qué tantos cacharros.
No se oye. ¿Puedes reproducir algo?
A ver, habla, Javier.
Hola, hola, ¿me escuchas?
Sí, ahora sí.
Ah,
Súper.
qué alivio.
Bien, bien.
Nada, pues
Apago el teléfono entonces.
el amplificador y la mesa de mezclas.
Uf, vale. A ver,
Mira,
¿cómo lo ajustamos así un poco para que se oiga bien?
¿Me sigues escuchando bien?
A ver, habla.
Hola, hola, ¿qué tal? ¿Me
Vale.
escuchas? Uno,
Ahí,
dos.
perfecto. Sí, perfecto.
Vale. ¿Practicamos lo de compartir pantalla o...?
Sí, si puedes mirar si puedo. ¿Y esto por qué no sale ahora?
¿Lo tengo que hacer yo o...?
Espera.
Hay que poner... computers. HDMI, no me acuerdo.
Vale. Y ahora te tengo que dar... Vale, ya está. Ojo. Gracias. ¿Puedes compartir pantalla?
A ver. Host disable participant screen sharing. No. Tienes que dejarme.
Ahora. Deberías.
Vale. Yo lo tengo dos veces. Déjame ver una cosita aquí.
Digo, no sé
¿Cómo
qué
lo-
poner aquí, pero bueno.
Porque si yo hablo ahora desde aquí, se me oye a mí.
¿Ahora?
Perfecto.
No. Espérame, es que lo necesito en la otra pantalla. Es que tengo dos pantallas. A ver, déjame intentar esto de nuevo. ¿Dónde se fue?
Vale, espera, voy a quitar ya la llamada. Allá cortaste.
Sí, ya corté.
Si habla la gente del público, ¿tú los escuchas? A ver, habla este. Hola, hola.
Sí,
Vale, pues si hacen alguna pregunta. Pero
perfecto.
te digo que últimamente la gente, como está online, se quedan en sus despachos escuchándolo de fondo. Más
Muy
que...
bien. ¿Cómo lo ves ahí?
Bien. Veo tu PowerPoint.
Vale.
Ponlo en modo presentación.
¿Ahí?
Ahí veo lo que tú ves. O sea,
Vale, entonces ya lo tengo. Ahora sé lo que tengo que hacer. Esta. Ahí.
Ahí estamos. Ahí la has dado. Perfecto.
Entonces yo no me veo en la pantalla.
¿Tú te ves o no te ves?
No, yo no me veo, no, pero no necesito verme. ¿Eh?
Vale. Bueno, lo dejaré así en 2 cuando yo que te hago la presentación y ya te doy paso y todo tuyo, ¿vale?
Vale, ¿qué hora tenemos? Son
-5, esperamos hasta ahí 5, ¿vale? A ver quién viene y si no arrancamos.
Vale, entonces yo no me voy a ver en la pantalla y... Mira, tú cualquier cosa te metes y me dices, ¿vale? Porque a veces un poco raro cuando estás hablando, no sé, me dijiste 40 minutos o algo así,
Sí,
y como que siento que no hay nadie ahí, estoy hablando solo, no sé.
sí,
¿Vale?
pasa, a veces pasa. Vale, yo te voy diciendo y si, bueno, ahora tú, si quieres que te corten entre medias o te hagan preguntas o prefieres del tirón y luego...
Mira, si quieren, sí, si quieren que me corten también, incluso mejor. He hecho presentaciones y se me hace como raro un poco.
Ya, 40 minutos es muy largo.
Claro, como que estoy hablando al vacío y
Sí. No, lo que haremos es como casi todo el mundo luego estará por YouTube,
ya.
que de hecho, voy a conectarlo aquí.
Oye, vamos por inglés, me dijiste, ¿no?
Sí, 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 por favor.
Sí, sí. No, está todo en inglés.
Mira, se ve guay. Pues a lo mejor lo que tenemos que hacer es...
Ahí.
A ver, y la otra cosilla, antes que me olvide, se me apagó el audífono en un minuto cuando lo practiqué. Si eso me pasa, me lo avisas también.
Vale, vale, vale.
¿Vale?
Te aviso, vale. Y luego al final, como hay muchas... Como está por YouTube y los oyentes pueden dejar preguntas en el chat, al final mi compañera te irá diciendo, si hay alguna pregunta, te lo decimos desde aquí, ¿vale? Y las vamos respondiendo.
Vale.
Para la radio.
Ah,
Pepito pregunta que no sé qué, no sé cuántos.
vale.
¿Vale?
Muy bien, muy bien.
Vale, pues voy a dar un salto al baño y en 5 minutitos nos ponemos.
Perfecto, cuando digas.
Hay enchufes en esta sala. Esto no va. No tengo batería.
¿Este no va?
No,
¿Por qué va a estar desconectado?
no, debería estar conectado.
¿Has probado en varios?
Sí.
¿Ves al final?
Pues si no me pongo ahí al final y.
Y luego te vienes para adelante, vale. Porque... Qué triste. O sea, vacío atrás de todo. ¿Cuánta gente crees que demora?
Si te nos cuentas a ti, amigos.
Buenos días a todos, son las 11. Para aquellos que estéis conectados, vamos a esperar 5 minutitos para ver si algún rezagado se une a esta charla de hoy. Vale, comenzamos, Javier. ¿Estás listo?
Sí, claro.
Bueno, buenos días a todos. Ante todo, gracias por estar aquí otra vez más en un nuevo webinar dentro del ciclo SEAMPOSIUM Dealing with New Frontiers of Marine Research. Voy a cambiar a inglés ya que este simposio es a nivel internacional. Thank you very much, everybody, for coming today to this new webinar on the Symposium cycle of conference. Today we have Dr. Javier Atalah from the University of Alicante in Spain and the Catherine Institute in New Zealand. Javier is a researcher at the Department of Marine Science and Applied Biology in Alicante and the Catherine Institute, which is the largest independent research institution in New Zealand. His main interests are the interactions between aquaculture and the marine environment, climate change, and the ecology and management of invasive species. Today, Javier will present a talk with the title On the Wrong Track, Sustainable and Low-Emission Blue Food Diets to Mitigate the Climate Change. Thank you very much, Javier, to accept this invitation, and the floor is yours.
Good morning, everyone, and thanks, Paolo, for the introduction and the invitation. As you mentioned, today I will talk about sustainable and low-emission blue food diets to mitigate climate change and explain why we're on the wrong track. First of all, I would like to acknowledge my colleague and co-author of this work, Professor Pablo Sanchez, also from the University of Alicante, that encouraged me to dive into the blue food world. So blue foods are derived from aquatic animals or algae that are caught or farmed in freshwater and marine environments. Blue foods play a crucial role in global and food security, providing a significant proportion of animal protein to a rapidly growing world population. Blue foods are a healthy protein source, rich in essential micronutrients, minerals, and fatty acids. And the production is increasing, and as a result, they're becoming one of the most traded commodities, supporting jobs, livelihoods, and income worldwide. The global consumption of blue foods is in the rise, with per capita consumption in 2020 estimated to be at 20.2 kilograms per capita. Blue foods account for 17% of animal protein consumption. But in some countries, in Asia and Africa particularly, this proportion can reach up to 50%. blue foods is a very important part of the Spanish diet, which has one of the world's highest per capita consumption of blue foods. With 42 kgs per capita, it's second in Europe, only behind Portugal. The global production of blue foods had been estimated at 178 tons in 2020. And where you can see in this graph, the aquaculture production has steadily increased in the last 70 years. The production from wild fisheries increased up to 1990 and then has remained relatively constant throughout time. As a result, blue food production has changed drastically in the last decades due to aquaculture expansion and the limited supply from wild fish. So in 2019, aquaculture accounted for 49.2% of the production and contributed to more than 50% of human consumption, fish for human consumption. At a European level, this proportion is considerably higher, reaching up to 76% of fish coming from wild fisheries. So on one hand, fishery resources are continuing to decline due to overfishing, pollution, poor management, and other factors such as habitat destruction. For example, trophic cascade effects as a result of overfishing has a huge ecological consequences, as fisheries can remove top predators that have consequences in other levels of the trophic web, affecting the whole ecosystem. However, in most cases, blue food production systems are generally advocated as a sustainable source of protein because they generally have a better performance than other animal protein sources, particularly from terrestrial environments. So sustainable production systems such as viable aquaculture or low trophic level fisheries have environmental footprints that are quite low and comparable to the lowest animal protein source from terrestrial systems such as the chicken, for example. However, poorly managed blue food production system can have an enormous impact. So including habitat degradation, wildlife and biodiversity impacts, nutrient enrichment, fish escapes in the case of aquaculture, and greenhouse gas emissions. In many cases, the high prevalence of diseases and parasites due to high farming densities, translating excessive use of antibiotics, hormones, pigments, and other pharmaceuticals. For wild fisheries, these impacts can include stock depletion, bycatches, ghost fishing, and food web alterations. So it's really important, crucial to blue foods is to improve a production system and minimize their footprint, so we can sustain a blue food contribution to food security. This context, food consumption choices allow citizens like us to take actions that reduce the environmental burden of food production, and at the same time tackle the climate crisis. Shifting to balanced, sustainable, healthy diet has been suggested by the Intergovernmental Panel of Climate Change as a significant way of mitigating the worst impact of climate change. Sustainable, healthy diets include animals sourced from producing resilient, sustainable, and low emission systems. So having a better understanding of the environmental performance of different types of blue foods can promote to sustainable diets. So for this, we wanted to understand how changes in the consumption trends of fisheries and aquaculture products in developed countries with high seafood consumption can help to mitigate climate change and environmental impacts. So for this, we evaluated the case of Spain. The specific objectives of the study that I'm presenting today were to assess the trends in blue food consumption in relation to type, protein source, and specific trophic level. species trophic level, sorry. And secondary was to assess, or secondary, not secondary, the trends in stress and emissions, including greenhouse gases, nitrogen, and phosphorus, resulting from the production of farm species and wild fisheries. So for this, we extracted consumption data from a household survey conducted by the Spanish Ministry of Agriculture and Fisheries and Food. The database comprised monthly data collected between 1999 and 2021, 12,500 collaborating households that electronically recorded all purchased food and beverage for home consumption. This didn't include consumption outside home, so that doesn't include bars and restaurants, with it's been estimated to account for 20% of the total consumption. All the available data was downloaded, merged, and cleaned, and relevant variables were retained for the analysis, which included 52 unique blue food categories. This data set was then summed at a national level, and a range of descriptors were derived for each of the categories, including production source, trophic food type, trophic level, and stressor emissions associated with the production. In terms of source, we classify the food categories into wild, farmed, and mixed, based on expert knowledge and existing literature. Most blue food categories were of wild origin. So those were captured by fishing fleets locally and globally. And farm species included salmon, mussel, sea bass, rainbow trout, turbot, and sea bream. There was a third category that referred to as mixed, that included blue food sourced from a combination of wild fisheries and aquaculture that included shrimps and prawns, clams and cockles, among many others. In addition to each blue food category, we derive the trophic level based on the species from fish base. Trophic level is defined as the position of a species in the food chain, and it ranges from 1 to 5. Where values of 2 represent a herbivorous species, intermediate predators have values around 3, and top predators have values larger than 4. Then, to assess the trends in environmental performance of blue foods, we obtain a standardized estimate of stressors emissions associated with the production from published sources. In particular, we obtain greenhouse gas emissions, nitrogen, and phosphorus from a publication from Giffard et al. 2021. These estimates are based on system inventory data that considers full use, feed composition, on-farm and energy use, and yield. And these estimates are based on existing life cycle assessment studies and literature. Because transport is also responsible for a large proportion of the final carbon footprints, we adjusted the greenhouse gas emissions for imported foods. Adjustment accounted for differences in the distance between the capital of exporting countries and the proportion of local production obtained from national agriculture reports. 3 of the 6 farm species are locally farmed, which are mussels, trout, and turbot. So no greenhouse gas adjustment was required, although virtually all salmon is produced in Norway, where sea bass and sea bream are produced locally and in other countries, mainly Greece and Turkey. So now going to the results. This is the summary of the consumption throughout the 22 years of data. So historically, species of mixed sources, farmed and wild, here in the middle, were the most eaten blue foods, with an average per capita consumption of 1.4 kilograms per month. Now we'll be talking about a monthly per capita consumption. So the most popular blue food was mollusks and crustaceans that exclude mussels, particularly fresh, with 400 grams of monthly consumption per capita. The most consumed wild species was hake, fresh being preferred over frozen, and secondly, canned tuna, exclusively canned. This was followed by squid, octopus, anchovies, flounders, and other species of sardines. For farm species, the most consumed species was mussel, that were consumed fresh, followed by salmon, sea bream, sea bass, trout, and turbot. These quantities were relatively low compared to mixed and wild blue food consumption. Looking at temporal trends, we can see that monthly total consumption peaked in March 2008 here with 3.4 kilograms per capita, and then steadily declined through time, except for a peak in 2020. And you guessed it right, that was because of the COVID-19 pandemic. So during which all hospitality sectors were closed and the consequent increase at home consumption. Mixed and wild consumption follow a similar pattern compared to total consumption. However, farm consumption, which was relatively lower, increased over time, which almost doubled in the plus two decades. If we looked at seasonality here for fresh, frozen, and preserved blue foods, these are different years from 1999 to 2021. We can see there's a marked seasonality with a strong peak in December, and another one, a weaker one around April, which coincided with Christmas here in December and April for Easter. So digging deeper into wild species consumption, as I said, the two most popular species were hake and tuna, canned tuna. Well, hake, is traditionally the favorite fish of the Spaniards, so accounting for 12% of the consumption across the study period. However, there has been like a steep decline in the last 10 or more years, both for fresh and frozen hake. So the high demand and the fact that most European hakes stocks are overexploited has triggered a global trade of other hake species, particularly in South America and Africa, which has caused a significant rise in the prices, and we suspect that this rise in prices may explain the sharp decline in hake consumption of the last 2 decades. Hake consumption was followed by tuna, another central item of the Spanish diet, but which has steadily increased over the years at a slower rate, but a significant increase. And I guess this tuna consumption supports Spanish tuna canneries that lead the European production. They produce 68% of the tuna cans and rank second worldwide. In terms of farm species, as I said, mussels and salmon were the most consumed, but these two species provide two distinct examples of consumption and production patterns. So on one hand, mussels are locally produced, whereas salmon are virtually all, they're all imported. Mussels are a low trophic level species that are extensively farmed, that relies on natural food, spat and space for the farming, whereas salmon is intensively farmed, is a high trophic species and requires considerable amount of feed inputs. So mussel has declined considerably over time, mostly fresh, but similar pattern for smaller proportion of frozen mussel consumption. The consumption of salmon, on the other hand, has increased like substantially over the last 2 decades, mostly fresh, but also for preserved and frozen. The introduction and rapid expansion of field fish aquaculture in the 1980s has translated in this increase not only of salmon, but also in the increase of the consumption of sea bass, and to a lesser extent of sea bream that was more variable due to fluctuations in the market availability because of diseases, escapes, COVID-19, among others. On the other hand, trout, which is the only land-based fish production system, inland, freshwater. So this one has decreased over time significantly. And turbot, that is also produced mostly on land, but being a marine fish, is an emerging species still with low consumption, but has increased over time. These are the examples. I'm not going to go into detail, but I just want to highlight there's quite a complexity in patterns here, but I want to highlight the trend of small pelagic fish, including anchovy, sardine, and mackerel, that has a decrease over time. Sardine, for example, sharp decrease over time. Squid and octopus, also from wild sources, have declined considerably. And these low trophic level species, they represent examples of sustainable fisheries associated with low stressor emission, but they also provide high nutritional value. Now, if we looked at these consumption patterns by trophic level, through time again, we have the farm species here at the top, split by trophic level. So medium trophic level, low trophic levels, mainly mussels, decline a little bit, but it's been relatively constant through time, whereas medium trophic level, farm trophic level species increased up to 2009 and then remained constant, with another increase in the last 5 to 10 years. This mostly because of sea bream and sea bass, whereas high trophic level species, salmon, turbot, has increased over time, with a marked peak in 2020. Again, this, as I said, mostly due to the COVID-19 pandemic, which is a common trend across all time series. For mixers, bluefoot, this follow the general trend of consumption that I showed you before, that increased up to 2010 and then declined, apart from the peak in 2020. And wild fisheries similarly decreased over the study period, but there was an increase here of low trophic level species, but otherwise they remain pretty constant through time. Now, if we looked at the carbon emissions, these are estimates from at the farm gate level, so that is excluding transport. So this was done initially because to determining the origin of mixed and wild bluefoots can be very challenging, as they come from a range of sources, and in many cases uncertain. So we couldn't adjust it to transport. So initially we calculated the farm gate carbon emissions, so that stopped at the farm or when they're caught. So aquaculture in general and fisheries emissions are relatively modest compared to other terrestrial production, because mainly they don't produce enteric methane as cows or other terrestrial animals. And also they have a relatively low feed conversion ratio in terms of fin fish and shellfish. For example, a kilogram of bluefoot consumed generated an average 7.5 kilograms of CO2 equivalent of greenhouse gas emissions, compared to beef emissions that can be as high as 50 kilograms of CO2 equivalent. So here we can see that sea bream and sea bass are particularly high among and turbot among farm species. Mixed shrimps and prawns are quite high. And for farm species, wild species, flounder produce quite high emissions, I guess, being mostly caught by trawling. They can produce a lot of habitat destruction. So now if we multiply these emissions for a species and for the production, consumption, sorry, we can see as expected that emissions per capita follow a similar trend to consumption. So they picked in 2008 at 26.4 kilograms of CO2 equivalents per month per capita. So then they decline until 2020, again, there's a peak here, but they remained around 20 kilograms of CO2 equivalent per capita. While mixed and wild were relatively similar patterns again. Farm species produce lower emissions, but they have almost doubled in the last 2 decades. So to put it in context, an average passenger car emits around 120 grams of CO2 equivalent. This has changed through time. They're getting a bit more efficient. So if we put it in context with what our data shows, the average total monthly blue food consumption per capita equates to driving a car for 200 K. So that's per person. So every month. So that's the equivalent of our blue food intake per month. So it was quite interesting. Then we focus on the performance on farm species only. So because nitrogen and phosphorus emissions are irrelevant for fisheries. And we estimated we adjusted the greenhouse gas emissions with transport. So imported species as sea bream and sea bass perform pretty poorly as a consequence of the transport from the origin production countries, whereas mussel, for example, perform really well, particularly on nutrients, because being a filter feeding species, and farm species, fish species, have a relatively high emission of nutrients, both nitrogen and phosphorus, and salmon was somewhere in between. So this is the last plot I'm showing you the results. It gets a bit complicated, but this shows the emissions for each of the farm species associated with the consumption. So we have greenhouse gas emissions at the top, nitrogen and phosphorus, which follow a very similar trend. So starting with greenhouse gas emissions, we can see the increase in the total emissions here in pink. These are the totals. And again, we have the peak in 2020, but there's been a relatively sharp increase in emissions associated to the consumption. And this has been mainly driven by the increase of the consumption of blue foods, of salmon, sea bass, and sea bream. As turbot, it's consumed in relatively low quantities, doesn't produce much emissions despite that having a big footprint. And mussel, the other way around, it's consumed in high quantities, but it has a very low footprint. In terms of nutrients, again, we have a sharp increase in the last, particularly in the last decade, I would say, with a peak in 2020, again, related to an increased consumption of carnivorous fish, sea bream, sea bass, salmon here in this gold. And interesting, for example, mussels produce negative nutrient footprint because they are intaking nutrients through their filter feeding activities. So that's for results. And now going to discussion, try to interpret what all this means in terms of consumption trends. Well, we observe across time series that there's been a sharp and a notorious decline in consumption since 2008, with a trend that coincided with the economic recession. So we think that this change in direction of the consumption patterns can be related to the economic recession. Spain was a notorious example of the economic impacts of the recession, which had cascading effects on food systems and dietary intakes. In general, it's typical for low-income consumers to reduce overall consumption on one hand, and to switch from high to low quality, starchy, staple food in response to rising prices and their declining purchasing power. So our take is that recession could have caused this decrease in consumption since 2008. Another hypothesis is could be related to an overall decrease in the meat consumption that follow a similar trend. So yeah, it could be related to a reduction in general reduction in animal consumption. But as I mentioned, there was a commonality across time series in 2020. There was a peak that were related to the pandemic, so which highlights that there are other complex factors that can cause changes in the pattern of consumption that can be quite unpredictable, of course. And yeah, in this case, you know, the lockdown caused that people was consuming more at home blue food and impacted not only consumption, but also production patterns, and had a series of impacts throughout the fisheries and aquaculture. So another pattern is that there's been a rise in the consumption of carnivorous fish. And this has been termed as raising the tigers of the sea by famous paper by Naylor, which described and evidence the farming up effect that the aquaculture industry has experienced in the last 20, 30 years or more, 40 years since the 80s, basically. So we have a growing demand for medium and high trophic species that has sustained this industry of carnivorous species that require large amounts of animal feeds that are derived from small pelagic fish, which are that could be available for direct human consumption. So these fish are turned into animal feed to produce a relatively small amount of fish destined for more affluent consumers. So that's the role of carnivorous fish. Aquaculture in food security has been criticized for being a net fish consumer. So despite the recent advances in fish nutrition, genetics, and alternative feed types that has significantly reduced the reliance on wild fish, feeding is still the most significant contributor to fish nutrients and carbon emissions. That's why in the previous slide I showed that salmon with eating like a vegetarian salmon. That's kind of where is the industry leaning towards, but feeding still major factor. And eating feed and fish waste are additional sources of nutrients. So in this context, a critical parameter is feed conversion efficiency. So sea bass and sea bream, for example, had feed conversion ratios of around 2:1, but they can reach up to 3:1 depending on season and reproductive status. That can vary. These are quite low ratios compared to trout or salmon, which are way more efficient. That could be as high as 1:1. And that's what explains the difference is in the emissions that we detected. So here, land-based systems such as RAS can provide a more sustainable option as they use feed more efficiently. And in turn, they reduce the generation of waste and nutrients that can be treated and released in a more controlled manner. Here, mussels provide an example of net zero blue food. So across all the species, consumption of locally farmed bivalves was associated with the lowest stressor emissions. Spain is the largest mussel producer in Europe, supplied nearly all the demand for mussel. Shellfish farming provide vital ecosystem services such as sequestering nutrients and suspended particulate matter that are taken from the phytoplankton and converted into mussel tissue. And these nutrients are then extracted from coastal environments and when mussels are harvested. Although they sequester and dissolve in organic carbon when they form their shells, they also tend to release CO2. So in terms of CO2, they are like a zero contributor or maybe a very small contributor to CO2. So again, transport was also a significant contributor to greenhouse gas emissions. So transport of the 3 imported species, farmed fish, accounted for 50% increases in greenhouse gas emissions. And overall, during the study period, nearly half of sea bass and sea bream were consumed in Spain were imported from other countries. In 2020, this proportion was very small. Only 26% of consumed fish were sea bream were locally produced. So in the EU, there's a trend for decreasing internal production compared to the world growth of aquaculture. And this implies that the need for import large quantities of blue foods each year. So this reliance on imported produce to satisfy local demand highlights the importance of eating locally sourced foods that has a huge impact on the performance of our consumption patterns. So now going into the recommendations. So of course, the main or the most meaningful action we could take as citizens is to reduce the protein consumption and animal consumption in our diets and consuming locally, of course, which has significant environmental benefits. But however, switching to diets based on more sustainable foods could also be nearly as effective as going vegetarian. Not everyone's going to go vegetarian or vegan. So, for example, carbon emissions associated to wild blue foods are 6 times lower than beef. So, switching from animal produced protein to blue foods it's a substantial improvement. However, the trend is to move towards more plant-based options to put less burden into the sea. But for example, moving from a carnivorous fish diet to mussel diet could reduce your stressor emissions by 10 times. That's a very significant reduction. But even favoring local over imported sea bream and sea bass could reduce your greenhouse gas emissions by 1/3. Or for example, choosing locally produced trout could reduce them by 2/3 compared to sea bass and sea bream. So similar gains could be accomplished by favoring sustainable wild-caught blue foods such as anchovies and sardines over carnivorous fish, or shrimps and prawns that are imported from distant countries and caught with unsustainable fishing methods. So in terms of recommendations for minimize or pathways to minimize greenhouse gas emissions, particularly for fed fin fish aquaculture, targeting species and production methods that perform better in nutrition and climate, as well as reducing emissions, is highly recommended. For fed fin fish aquaculture, this could include sourcing feed and juvenile from local facilities, reducing feed conversion ratios, optimizing feed use to minimize waste, optimize farm spatial planning that minimize the impact on blue carbon habitats, for example, such as seagrass, reduce the source feeds from local farms, and also monitor the sediment for carbon and nutrients. This needs to be in conjunction with policy efforts that has to afford they should focus on incentivized mitigation measures provided by researchers, such as these studies, for example, that provide mitigation options that can be translated in more efficient farming production systems that monitor their emissions, that are validated and communicated towards the consumption and production chain, so the consumers are better informed. And this, for example, could be implemented as eco-labeling systems, such as the ISO system that help to identify sustainable products. And other important initiatives can relate to reducing blue food and packaging waste to improve the environmental footprint of our diets. And finally, I would like to share, because promoting it and the education and promoting the awareness to encourage more sustainable and healthy consumption can have a significant impact on the blue food environmental outcomes. So I wanted to share this campaign that was apparently very popular in the 80s, as I hear, that promotes the consumption of mussels as a local produce, and it's highly relevant today in the context of climate change and nutrient emissions and etc. So very interesting. And to finish this presentation, just want to summarize all this our findings. So we can say that over the last 22 years, there's been a drastic change in blue food consumption patterns in Spain. There's been an increase in the consumption of farmed carnivorous fish and a decrease in the consumption of mussels. These patterns translate in contrasting stressor emissions with high trophic level species responsible for a large share in stressor emissions. So the consumption of imported salmon was associated with stressor emissions nearly an order of magnitude higher than the best performing blue foods, which are mussels. So in this context, our results shows that consumer choices of foods of different sources, species, and origins are associated with disparate environmental footprints. So our results also evidence that consumption trends in developed countries such as Spain may be not as sustainable compared to diet based on low trophic level blue food, such as bivalves and algae. So based on our assessment, we recommend refocusing our diets and consumption patterns towards farm species with small environmental footprints, such as locally produced species, low trophic species, such as mussels, and implementing policies that increase consumers' environmental awareness and minimize the footprint of the production systems. Finally, I want to share the publication of this work that is just fresh off the press. It's coming out in the next few days in Frontiers in Sustainable Food Systems. And yeah, where you can check it out and see all the details of these studies. And finally, wanted to acknowledge the funding for this work from Maria Zambrano grant and the Thinking Azul program supported by the government through both through the European Union Next Generation EU program and the Generalitat Valenciana. So thanks very much for your attention, and I'm happy to take questions.
Thank you very much, Javier. It was a really, really nice talk. There's a lot of information, a lot of fresh data, and what I like the most is a lot of home take messages from them for the consumers. That I think that we as a society we have a lot of power to make things change that we don't use enough.
That's right.
I don't know if I have some questions. I don't know, but the people in the chat are a bit shy today. It's Monday. Please share your questions or your ideas in the chat so we can share it with the speaker. Meanwhile, I have a couple of questions for you, Javier. For instance, do you see realistic the replacement of consumption of more invertebrates or more non-carnivorous fish species in Europe? I think there's a really a strong root in the habits as a cultural. There's a cultural root of eating fish, especially carnivorous fish.
Yeah.
What do you think would be realistic, or how would be this change or transition to this new way of consumption from your point of view?
Yeah, I agree. Like there's a very rooted culture of fish here worldwide, particularly in Spain. But I think the new generations are really making this change. And as I said, you don't need to replace completely your diet, but even replacing some portions or minimizing the proportion of your intake of carnivorous fish towards pelagic fish, small pelagics, or mussels, or species that are producing sustainable environments, production systems can make a difference. So I think it's possible. I think there's a big movement of people going reductionist or even not necessarily vegetarian or vegan, which there's a lot of that. So that's a global move, but even reducing the patterns of carnivorous and even beef consumption, I think it's happening. And I really do believe that new generations are an example in that regard.
Yeah, about the new generation, I actually think that they don't have the habit of buying the whole fish, but always buy products, like manufactured products.
That's right.
More frozen, and that's it. That kind of habit wouldn't be an increase in the carbon emissions, for instance?
Yeah, that's a good question. We look into different types, like fresh, canned versus frozen. For example, frozen and fresh, they compare similarly because there's two things. There's a lot of energy into the frozen processes, but they can be transported more efficiently. So you can pack maybe like several times more frozen food than fresh food. So they're more efficient to transport. And as explained, transport is a big contributor to emissions. So at the end of the day, they come out as similar. In terms of canned food, yeah, that's a good question. And probably I don't have the right answer, but again, it depends where it comes from. Like tuna, for example, they are produced locally in Spain. So that I think labeling has a really important role to play there. So as consumers, we are aware where, for example, canned tuna is coming from, which species is from. There's a really good project from, I think it's from your institute, it's called Planet Tuna, that they explain that and have a really good public campaign of education on explaining, because the tuna example, it's a very complex one. But I think if we make the right choices, if guided by projects like Planet Tuna, like they can help us to make the right choices.
Yeah, you're right. I mean, I think the education is always a powerful tool. In this sense, I mentioned before the society has a strong power. why it's not happening yet? Why these changes take so long?
Well, I think that's a more
I know.
psychological question.
Now.
So you mean why the change in habit takes so long, or?
Yeah, why? I mean, it's so clear these tendencies that you show us, no, that about the increase of the carbon emissions. It's so clear that it has been increasing and increasing.
Yeah.
Why is not changing?
I think as I said initially, it will take a generation. That's my personal belief, and I think this is beyond the scope of the study. There's a lot of factors there, but I think people now is realizing that climate change is real and it's happening and it's impacting us in our day-to-day in our life. So, and I think the new generations have that incorporated in their mind. So I see, my kids, they have that as a, ingrained in their life. So for them, it's normal. Whereas there's a saying like to teach a new trick to an old dog. It's quite hard, no? But I think it's a generational change.
I totally agree with you. I always think that, and it's not only one generation. That could be.
Yeah, I take more than one. True.
Yeah. Just a last question. The thinking on different strategies or management strategies. Do you think that, for instance, implementing some kind of green taxes or punishment, so to say, to those industries or sectors that produce the higher carbon emission could be effective?
Yeah, I mean, I'm not very. I don't really agree much with punishment in general, but I would see more. I mean, the industry is already struggling with many factors and processes, including climate change and diseases and the pandemic. So imposing more restrictions could be a bit challenging. I guess it could be more incentivation or like promoting good practices rather than punishment. I see that would be the way forward, like in terms of if they provide clear labeling or monitoring all their practices and production systems. So we are more aware of what we're eating, and it's like eating organic food sort of thing, or like produce sustainable food in the long run. That will have a benefit on their products. So I'll be more inclined towards a strategy like that than punishing consumers, or I mean producers, sorry. But yeah, I guess it's always an option. Yeah, in terms of taxes, I guess it's already a punishment for imported products, but I guess again that's a bit outside of my domain, but it already has a economic, or they managed to go across that for countries that can produce cheaply and then still manage to pay those taxes.
Mm-hmm. In this way, there are different certification levels on sustainability, also on welfare coming up. I believe that this is also a small change in the path. What do you think about this kind of strategies?
Yeah, I definitely think that eco-labeling could be more comprehensive, as you say, welfare, labeling, and emissions now in terms of nutrients, greenhouse gas emissions, origin. So in Europe, there's a really good eco-labeling system. I mean, or labeling system of origin and species, and the type of gear they use for wild fisheries. But yeah, this could be expanded to other areas of sustainability. Yeah, totally agree. Mm-hmm. And that would empower consumers to make the right choices, because it could be a bit overwhelming you're in the supermarket and then go online and try to find if the fish you're buying is the right one, or if they offer you that in a clear, concise manner. That would be fantastic.
No, in this point, I think it's important also, again, education to the consumer to choose the right product and to identify these labels and certification that we, as consumers, most of the time have no idea what it means.
Absolutely. Yeah. So I think there's a lot of work to be done there.
Okay. Thank you very much. There's no questions in the chat today. Again,
Yeah.
this Monday. Thank you very much to the audience. Just to let you know that this talk was recorded, and we will be available at the YouTube channel of Imedea for those who are interested in watching later. And of course, I guess that Javier will be very happy to answer any questions afterwards through the email or
absolutely. Yeah, totally.
Thank you very much, Javier. Thank you.
Thanks, Paulo, for the invitation. Yeah, my pleasure.
Bye. Have a nice day.
Bye. You too.